as Dr. Ash said, my name is Samantha Shapiro. And before I go any further, I want to, first of all, thank Reverend Donovan for making this gift which enabled the creation of this fellowship. I am humbled and truly thankful, and I honestly can't put into words how much this means to me. I can just promise to do my very best to get the absolute most out of this fellowship. And I want to thank Dr. Ash for selecting me. So, a little bit about me. In order to understand how I ended up standing here in front of you, there is one crucial thing that you have to know about me. And that is that I am an absolute geek when it comes to neuroscience. In fact, and this is no joke but very serious, my last birthday party was neuroscience themed. We had brain cupcakes, there was a brain-shaped jello mold, and at the end of the night we all played pin the part on the brain. Now, it wasn't the most widely popular party game, but I could not have imagined a better birthday. So yes, I love neuroscience. And I mean, I've always loved science. I'm originally from Boulder, Colorado, home to the National Institute for Standards and Technology, the National Oceanic and Atmospheric Administration, and a small handful of Nobel Prize winners in physics and, I believe, chemistry, not neuroscience yet. So growing up around the University of Colorado, I was always surrounded by science, both in town and also at home. My mom is a pediatrician. My dad is a geologist who likes to think of himself as an amateur biologist, even though he has yet to learn what a cell actually is. My brother is so in love with science that he's actually studying engineering at Stanford right now. Today's his first day back, and I'm sure that he's already stressed beyond belief. So I knew very early on that I wanted to be a scientist. But I didn't really know what kind of scientist I wanted to be until I happened to take a psychology class during my junior year of high school. I don't remember very much about the first months of the class. I know that the professor's name was Mr. Greenman, and that he had a dog that liked to chase cars. But that's about all that I can recall. Now, my memories of that class don't really start until we began to branch out from the textbook, and we devoted 2 weeks to a unit on Neuroscience 101. I mean, going over the most basic parts of the brain, I found myself absolutely mesmerized. You know, the brain is not just interesting from an academic standpoint, but it influences everything that we do. The fact that the smallest alteration to a person's brain can change his entire demeanor completely blew my mind, no pun intended. And with that knowledge in hand, or in brain, and the fact that I was passionate about neuroscience, I applied to Macalester College, an institution to which I know the Donovan family has some familiarity, starting with Reverend Donovan's tenure as Professor of Classics in 1966. Now, I looked this up and I have to read my note card for it, but Professor of Classics, or as the Greeks say, hold on, I did have it on here. Well, it's something along the lines of...
Greeks talk too much anyway.
They do talk too much anyways. All right, let's cut that out. And this is why you don't use note cards during a talk, because inevitably you will not be able to find what you're looking for. Although, if you're curious, it's Katheates Archaios Ellenikis Philologias.
Which means?
Which should mean Professor of Classics, although trusting Google Translate, it might mean like lone wanderer of the hillside. So, if anyone speaks Greek, feel free to correct me. Otherwise, let's assume that I'm right and he's Professor of Classics.
You'll go far, are you not?
So at Macalester, I was one of only 2 people in my graduating class to actually pursue a neuroscience major. I don't know why there were so few of us, but it actually turned out to be a good thing because I was able to get a kind of thorough introduction to research and to realize that it was something I was absolutely passionate about. So before I graduated in 2011, I started looking around for well-regarded labs where I could get some knowledge and expertise before going on to graduate school. And I was lucky enough to find the Grossman Center for Memory Research and Care, and I started working here, first as a volunteer, and then later as a full-time employee. So that's kind of my story about how I got here. Now, since I've been here, I've learned so much, both about Alzheimer's and about people who are affected by Alzheimer's disease. And for me, the reason that I came to this lab is because I'm interested in both the scientific and the personal. You know, I think the scientific I love all things brain, and I'm fascinated by what happens when the brain goes bad. But the personal for me is a lot less academic. I myself have some family members and close family friends who have recently been diagnosed with Alzheimer's. So I know just how devastating this disease is, both for those who are affected by Alzheimer's and also for those who are connected to or have to take care of those who are affected by the disease. So working here, I feel like I can make a difference, even if it's the smallest difference. And if I can contribute any piece of knowledge or any scientific discovery towards this fight, then that would mean a great deal to me. So since I've started working here, I've learned so much, both about the disease and also about the people who have Alzheimer's. I've learned techniques ranging from protein analysis, enzyme analysis, DNA analysis, and things as far-ranging as high-throughput screening to determine targets for drugs, to designing behavioral tests to be used to determine whether animals have cognitive deficits. Now, as is the case with any research, some of my projects have been more successful than others. But through it all, I've gained a deeper appreciation for the research process and a greater understanding of just how scientific discoveries arise out of the work that leads to them. So, at the moment, my current research topic concerns a line of mice that died out in 1996. Now, you will not have to learn this or memorize this, but the mouse line is named 2123H. Now, the 2123H line is a transgenic line of mice, which means that they have a mutation. And this particular line of mice has a mutation that causes them to have human APP. APP stands for amyloid precursor protein. And it's a protein that breaks down into amyloid beta, which then forms into the amyloid beta plaques, which many of you may have heard of. They're one of the hallmarks of the disease. Now, the 2123H line was characterized by early death within just a couple of months after they were born, and a very rapid onset of symptoms. Now, at the time, the techniques that were around to examine proteins and to figure out which specific proteins were present in the brain weren't as advanced as they are today. So Dr. Ash and her fellow scientists weren't really able to uncover what led to this early death and advanced symptoms. So when the line died out in 1996, a fair number of the brains were frozen for future use and future analysis. And in the future, that is where I come in. So at the moment, what I'm doing is that I'm looking at these brains that have been frozen since 1996 and going through and comparing what protein species are present in those brains that have this mutation and thus produce human APP versus those proteins that are present in those that do not have APP and thus do not have Alzheimer's. And although it is very early in the research process, we believe that we may have found a protein that may be involved. So this protein is found only in those mice that are transgenic and thus have the APP mutation. It's not found in those that are wild type or not transgenic. And it is found in relatively high amounts in the brain. Now additionally and interestingly, a protein that appears to be the same size as what we think we found has also been discovered in other mouse lines that have the other transgenic mouse lines. And it's also been seen in some cerebral spinal fluid from humans with Alzheimer's disease. So it's early in the process, and we still have to confirm the results that we've already obtained, as well as make sure that nothing is an artifact of the scientific process, and confirm that this protein does correlate with cognitive deficits. But we're tentatively hopeful, I would say. Now, the cognitive deficits, matching those with the protein of the brain, is something that is a little bit tricky. Since this mouse line passed away in 1996, it's hard to match behavior to what's in the brain. Now, there is some behavioral data for this mouse line, but it's incomplete. And unfortunately, humans, you can't actually use them as study subjects. And by unfortunately, I mean for the field, not for the people, because it would be very bad to use humans as study subjects. So what we're trying to do in order to study how the mouse's behavior might correlate with this protein is that we're actually working on recreating this mouse line. So we're using genetic manipulation to basically alter the genome in such a way that we can make mice produce this human APP. And hopefully we'll be able to see similar behavioral profiles, similar patterns of deficits and death that we did in the 2123H line. Now at that point, if everything works out, we'll be able to study in more real time both the behavioral and the biochemical aspects of these mice. And if this protein does turn out to match up with behavior, and it does turn out to show up in humans as well, then it's possible that it may play a role in Alzheimer's disease. So that's very exciting. Now, even if we are able to completely recreate the T123H line, it's important to know that this will still not be a perfect model of Alzheimer's disease. Unfortunately, there is no non-human animal that actually gets Alzheimer's disease. So all that we have are transgenic animal models that we create. Some of these mice, they develop plaques, some of them develop tau tangles, some of them have neuron death, but there really isn't a single mouse species that has all of those attributes of Alzheimer's disease. So another possible outcome of recreating this mouse line is that if it is successful, and if these mice do display the behavioral deficits, cognitive deficits, and extreme symptomology that we've seen earlier, we might then be able to breed that mouse line with another mouse line and hopefully try to get a more accurate representation of Alzheimer's disease in an animal model. And that's something that those of us in the Grossman Center for Memory Research and Care are working on, is trying to create this model, because the field as a whole really needs it. And in order to make sure that we can fully understand the disease and fully study it and make sure that what we're discovering is accurate and impactful, an accurate mouse model is really important. So we're working on that here, and hopefully we're going to get it. Now, as I have mentioned numerous times, this is still in its very early stages, at least the project that I'm on. The overwhelming Alzheimer's project, of course, is a long time in the works. But, it's exciting, and it's something that I'm really excited to be working on. So even if I'm not here to see it through to the very end, and even if things don't work out perfectly, but fingers crossed that they will, it's just such a privilege to be working here at the Grossman Center for Memory Research and Care. I know that for myself, and I'm going to speak for everyone else, feel free to object if you want to, but at least for me, this is more than just a job. It's an opportunity both to contribute to the fight against Alzheimer's and also to impact, in a positive way, those who have Alzheimer's and those who are trying to learn about the disease. So I truly cherish my time here, and I want to thank you for providing this fellowship, which will hopefully enable me to do more good work. So I think that what I've done here, both coming to an understanding about the disease itself and also about those who are impacted by the disease, has made me realize that I really do care both about the scientific and the personal. And ultimately, that's what drew me to this field and to this lab in the first place, is the melding of those two. So right now, and hopefully this won't change anytime soon, but my plan is to pursue an MD, PhD in neuroscience. I think that the MD will allow me to have the human interaction to see the impact that the research is having firsthand, and the PhD will enable me to sort of make my own difference in that. So those are my tentative plans right now, and I hope that, through the work that I do in this lab and through the work that I do in the future, I can make even the smallest little bit of a difference. Because ultimately, it does come down to the personal and the scientific interacting in a positive way. And I believe in positive things happening. So I'd like to be a part of that. So that's my story, my spiel. I apologize for the note card confusion. Greek is not my first language. And with that, I'd like to hand it over to Donovan for a few final words.
We're so glad you're a part of the lab.
Yeah,